Moving on, create X an array of the lot areas. Well, that is easy. X equals df all lot area. You can see there's X. What's the type of X? It's a series. I hadn't really noticed that when I prepared this. I don't think it matters because it seemed to work. Right, now it seemed to work even when X was a series, but just to do what I asked you to do, I've changed it to an array. Adjust X to have a mean of 0. That will have no effect on beta 1. But it will make gradient descent more stable. Now, in the code below, initialize the beta path with an NP0s matrix. Anitta plus 1 with 2 columns. This gives us a convenient empty matrix in which to store the beta 0 and beta 1 estimates as they change. Loss path is an empty list. In this case, initializing with the mean of y is going to give us the correct intercept. The 0 over here is the starting estimate for the slope of sale price with respect to lot area. Let's move on. Fill in the code below. Well, let's just look at some of what we did over here. We started with beta with the estimate that you can see, and we are now going to store all the betas that we estimate as we make the updates in the gradient descent. We're going to start by storing the initial estimate for beta on the first row. We'll calculate the loss, and we'll also append this loss to the path of all the loss. So at the end, we will have an array with the loss, which shows us how the loss reduces with each step of gradient descent. G over here is going to be the gradients, and G mag is the magnitude of the gradients. If we just look a little bit more carefully at that, let's have a look at what G is. That's something pretty big. So I guess the magnitude, if we square this lot over here, that's going to be a pretty big magnitude. Let's have a look at it. Yep, pretty big. But it doesn't matter. That's our starting point. The question is, how is it going to improve with gradient descent? So with gradient descent, you need to decide when you're going to stop. We will stop when the magnitude of the gradient, so we will continue going as long as the magnitude of the gradient is greater than the tolerance, which I've set up here to be something pretty small. So when the gradient is very close to 0, that while loop will stop. We will limit ourselves to a certain number of iterations so that if we do something stupid, it doesn't carry on forever. Here we are limiting ourselves to 1000 iterations. If it reaches 1000 iterations without breaking out because we've found the minimum, then it will stop in any case. Fill in the code below. Find the gradients. Well, I've already shown you how to do that up here. This line gives you the gradients. Find the sum of squares. I've given you that as well. Take a step in the opposite direction to the gradient. So we're going to adjust beta. The opposite direction of the gradient would be minus g. But let's not forget the step size. So minus eta times g is what we want to do. Finally, calculate the loss. And that is it. We've done everything we need to do. This code should now run. It does. Each 100 iterations over here, it prints out the number of the iteration and the magnitude. You can see that the magnitude of the gradient quickly goes to 0, which means it's found the minimum of our loss function. It has found the values for beta 0 and beta 1, which minimize the mean squared error. So we've carried out a simple linear regression with gradient descent. The starting price for houses is $178,000, and it increases at $9.3 per square foot. Let's have a look at how the loss function changed as the beta 1 parameter moved towards its correct value. If you remember, we started beta 1 as 0. At that point, the loss function was massive, and then we took steps towards the correct value of beta, which is 9.3 at the top end there, and at that level, the loss function is 0. I encourage you to experiment a little bit, and please take as much time as you need to go through this workbook and make sure you understand what it's doing, because we will be doing more on gradient descent as we go through these 6 weeks. If there's anything you don't understand, please do post questions on Moodle. Thank you.